So, good morning to all of you, and welcome to this webinar coming from the SolidCAM Technology Centre in Barnsley. So, I'm Will. I'm one of the applications engineers that work here, and I'm going to be taking you through over the next hour or so what is new within SolidCAM 2022. Just for your information, this is a recorded webinar, okay, and because of that, we're just going to have everybody on mute for this, but if you have any questions, feel free to use the chat, which should be on the right-hand side of your screen. Okay, feel free to raise those questions at any time. I'll try to keep an eye on it as we go through, and we'll see how we go. Okay, so we'll launch straight in there. So, one of the major changes within SolidCAM 22 is the way that the coordinate system is defined. Okay, so what we can do now is we can actually use associative elements. Okay, so we can use our levels, so you can associate them to features on the model. We can do the same with our coordinate system origins, our directions, everything like that. Another benefit to the way that we've changed this is that we don't actually need to rebuild the entire coordinate system if we actually change the location of that coordinate system. It will just be a case of recalculating the operations, getting everything sorted in that way. Obviously, within 2021, the coordinate system was not associative. And if you had to change a change in the part and you had to then change the location of the coordinate system, you would then have to redefine the coordinate system incomplete. Okay. If you wanted to make the edit to the location of the coordinate system, you'd have to restart that from the beginning. Okay. So it's a big step forward on the coordinate systems into 2022. Okay. We also have now some additional options, okay, as to where we want to be placing that coordinate system to. So I'll just take you through that in a second. So, most basic form is the auto location, and what that does is it snaps the coordinate system to the closest point on the auto box, so that bounding 3D sketch. Okay, so if you were to select maybe the top of the part somewhere in the middle, it would locate that coordinate system in the center at the top there. Okay, if I clicked closer to the corner, it would snap onto that corner. Okay. Taking that a little bit further, we've also got the auto location top. So if you want your coordinate system to be located on the top of a part, it will work in exactly the same way, but it's going to snap to the top. So it's not going to accidentally go to the bottom, midpoint, anything like that. And likewise, we've got the same on the bottom selection as well. So it's going to be picking up on that bottom point. Okay. Another one which we can do is we can actually pick up on cylindrical surfaces. So if you want to be, say, using a bore as your base for your coordinate system, you can do that, okay, and it will center itself at the center of that bore. Okay. As I mentioned right at the beginning, we also have the associative coordinate systems. So you can see on the right hand side there, we can actually define surfaces as our levels, so tool start level, clearance level, so on. Okay, and then we actually now have the delta field against that. So what that means is we can select the top of a fixture. We can then apply a delta to that fixture. Okay, so we can now have everything, all our levels based off of that fixture. So if we know we want to be clearing that fixture by 15 mil, for instance, we could set our tool start level or our clearance level as the top surface of that fixture, and then apply a delta of 15 mil, and it's always going to apply that clearance level so it's still 15 mil above that fixture, even if that fixture was to change. Okay, when I say even if that fixture was to change, as long as that face is still available. So for instance, if it was to increase in thickness or decrease in thickness, it's still going to take its levels as to be 15 mil above that. Okay. You'll also see now in the coordinate system manager, you'll be able to see any of the associative values. Okay, so in this example here, you can see that in Mach 1 position 1, we've got our tool start level. You can see with our clearance level, we've got a delta of plus 10. So our clearance level is 10 mil above that fixture. Okay. We can also, as I said as well, we can edit the coordinate system we don't need to rebuild the coordinate system from scratch. Okay, so if we wanted to change where our coordinate system was, let's say we wanted to change it from top center and we wanted to go to a corner, I can do that. Okay, I don't need to rebuild the coordinate system in its entirety. Okay, so a big advantage on there. It gives you a lot more flexibility in how you define your coordinate systems and how you can actually manage those after they've been created. So I'm just going to give you a couple of demonstrations as we go through this. So this is going to be one on the coordinate systems. So I'm going to load up a part that looks something like this. Okay, so we're working standard HASS-VF4 is a 3-axis machine. We've got our part somewhat in the middle and we've got these defined as our fixtures. If I go to my coordinate system manager, as we normally do, we've got our Mach1 and we've got our positions here as well. What I can do is I can edit these. Okay, so for instance, you can see now we've got our new select associative face. Okay, this is for our initial setup for our Mach coordinate system number 1. And you'll see as well, I've now got the options in terms of our auto location, so top, bottom, or just standard auto location. Just to show you how that's going to work, I'm going to use the auto location. And if I select, say, the center of this part, my coordinate system now snaps to be top and center. If I was to reset that and then click more towards this corner, you see our coordinate system has now snapped to that corner. If I select the bore, it's gone to the other side. Nice, quick and simple change. We've got our coordinate system like that. You'll also see we've got our modify origins. So for instance, I can pick my Z level. So if I wanted my coordinate system to be on that bore, but I wanted it to be on this face here, I can just select my pick Z level, select that there. You can see that now snaps that to the location that I'm after. We've still got all our modifications, so we can do the modifications by rotation or by delta, all the same as what we had in 2021. Okay, so that's just an insight into how that coordinate system is going to work. So I'll just accept that quickly. And I'll show you now the associative elements of this. So I've got my Mach1 position 1. I'm going to edit that. So looks pretty similar, but you'll see now we have the options of these deltas. So for instance, my tool start level, I want that to be the top of the clamps, and I want maybe that to be a delta of 50. So we're going to be starting 90 mil above our coordinate system. I'm going to do something very similar for our clearance level. This time I'll do, say, 15 mil in terms of the delta there. Okay. All of these are all associative. Okay. So I can leave that as it is. So if I accept that, you'll see now in my positions, my tool start level, it's going to be somewhere up here. My clearance level, 15 mil above the clamps, upper level, and my lower level there as well. Okay, so it gives you a lot of flexibility. What I can actually do is I can go back in there anytime. I can adjust that as I need to. Okay, so what I'm going to do, I'm just going to calculate all these operations. So we have something like that. So we can see our coordinate system, our clearance level is coming from there. Nice and easy. Let's say these clamps were to change. So I'm going to open this part up. Let's say this was to change to be 40 mil thick rather than 20 mil. Okay. Obviously, that's going to have a big impact in terms of my clearance level. So what I just need to do is I just need to get everything resynchronized. So if I just synchronize and calculate all, you'll see my clearance level has changed. Okay, it's adjusted and it's maintaining that 15 mil above the face that I selected. So if I go to my coordinate system manager, my tool start level, it's showing me it needs to be synchronized, so I missed that one there. You can still see it's picking up on that face there. It's going to be 50 mil above, likewise with the clearance level. Okay, so that's how the new associative coordinate system works and gives you a hell of a lot more flexibility in that sense. Okay. The next thing that I'm going to talk to you about is how we can actually share positions between different Macs. Okay. So I don't know if you noticed when I was going through that, the Coordinate System Manager did look a little bit different in that we've now split the Macs and the positions. Okay. This is all to do with the new flexible coordinate systems. Okay. It can be very beneficial if you are wanting to swap between machines quite frequently. Okay. So as you can see on this, with the new cam tree structure, we can actually see the relations to the Mac. We can drag operations between these Macs. So if we want to be moving these around between different setups, we can do very, very easily. In the operation coordinate system, only the position can be defined, and it provides a lot more flexibility. So we can set that position to be set up just the once, and we can share that within multiple Macs. Okay. This needs to be activated within the SolidCAM settings. So if you go to settings, into your miscellaneous settings, and then into the data options, you'll see you've got the option of flexible coordinate system. There does need to be some changes within the VMID. So if you are wanting these changes to be made, just get in contact with us via the support portal. Okay. One thing just to be aware of as well, if you open a part with the shared position mode, you cannot back convert it. Okay, just need to be aware of that. So if you are wanting to go back to the standard coordinate system, you will have issues at that point. So I'll give you a quick demonstration then on how this actually works. So I have a part something like this. Okay, multi-sided part, pocket on each side, and a lug on the top there. Okay, as I've set this up on our 3-axis HSV 4. Okay, so you can see I've got a top side, side 1, side 2, and so on. So what I'm doing here is I'm actually moving that part around to do each side. Okay. What happens though if I decided, actually I've got a 5-axis machine free? I could do this all in one operation. Okay, all in the one setup. And that's where this flexible coordinate system comes into its own. So I'm just going to show you how we do that. So if I change out of that HSV 4, and we'll use the Mazak CV5 500, so 5-axis machine, we can accept that. Okay. So we're now working on that 5-axis machine, as I said. If I look at my coordinate system, you see I've now got 5 Macs. Okay, just to show you where they are, one for each of those sides. What I need to do, or what I want to do, sorry, is I want to be using this Mac 5. Okay, that's going to be my top and center of my part. Okay, you'll see in here as well, we've got our 4 additional positions. Okay, so what I want to do is I want to bring basically everything into this top side setup. Okay, now in SolidCAM 22, that's very, very easy. I just select my operations. I can now click and drag those into my Mac 5. So you see I'm working on Mac 5, initially position 5, but we're going to be moving to position 1. So we're going to be working on this side here. We can do exactly the same for all the other sides. I click and drag that through. So we have all our operations all within this same setup using my Mac 5. So if I just check my setup on this, got our part stock out, make that slightly larger. And if I calculate now everything, it's going to do everything all within that same operation, all within that same setup. Okay. So just to show you that, let's simulate that in our machine sim for this part. So doing our top log. And we're moving on to our sides there as well. Okay, very, very easy to swap and change as we need to on this sort of thing. Okay, so what I'm going to do, I'm going to exit out of that. So we've done all of that in one go. One thing I would probably do on parts such as this is I've tried to optimize my order of operations. Within our milling operations, what we can actually do is we can use automatic sorting. We can sort this by tool number, so I'm minimizing now the number of tools or tool changes. So once that does its thing, you see using my tool 5, moving on to tool 7, so on. Okay, so a really nice handy feature has been added into 22, more so on the coordinate system and the position sharing. Next one to have a look at is simultaneous 5-axis edge braking. So there have been some developments on this one. The first one is the amount of tools that we can now use for this type of operation. So before we were quite limited. Okay, now we can use any of the tools that are shown on the screen as it stands. Okay, so it gives us great flexibility as to how we want to be breaking those edges on our 5-axis tool paths. We can also now create chamfers, and we can create those using our standard end mills. Okay, so they can directly cut those chamfers on, can roll around the corners, such as the example on the right hand side of the screen there. We can also control the contact point of that tool. Okay, so if we want to be cutting closer to the tip, we can do. If we want to be cutting closer to the shoulder, to the holder, we can do as well. We've got great flexibility once again in that one. Okay. Not only this, but we've also now got the option to actually round off some of these edges. Okay, so if we wanted to put a fillet on there instead of a chamfer, we can do using any of the ball nose type cutters. Okay, again, very, very handy. Obviously, we don't want to be deburring parts by hand if we can avoid it. So I'll just show you that quickly and how that works. So we have our parts, something like this. Okay. I've already created a couple of operations in this case. I'll just take you through what I've actually had to do on this. Okay, so that's our tool path there, something like that. I'll load that up. In terms of our geometry, we're looking initially at the entire target, okay, and then I'm actually controlling which edges I want to be breaking. Okay, with the fixturing involved on this part, I don't want to be doing any edge breaking down the bottom here. So what I've done is I've just selected the top face of this and it's picked up all of the edges around there. Our tool, we're just using a standard end mill. You can see on there, just a standard 4mm end mill. Okay, levels, nice and straightforward. But we've got our edge shape here, so we can either go constant width or constant depth. Okay, so on this case, I'm putting a 0.25 chamfer. I'm doing it with a single cut. Okay. Tool axis control, got our output, how we want this tool to be working. For something like this, minimal tilting in 5 axis is absolutely spot on. And now this is where I can control where on that tool that I'm cutting. Okay. Again, everything else is pretty much the same as what was on SolidCAM 2021. So I'm just going to simulate that, show you that. I'll do it in Machine Sim actually for you guys. Slow that right down. Not too much. You can see we're using that tool now. It's going to roll around that corner. Okay, putting that nice chamfer on. So very nice, very easy way of deburring your parts while they're still on that machine. Okay. As I mentioned, we've also got the option now to add on some fillets. Okay. Bear with me a second. Bring that up for you. So in terms of geometry, it's all exactly the same as what I did on the previous one, but this time I'm using a 4mm ball nose. You can see our ball nose tool here. Toolpath parameters. Because I've enabled the number of cuts along the edge, I now have the choice whether I want to round this off or whether I want to do a chamfer. So in this case, what I'm doing is I'm putting a 0.5 mm radius on that edge. Okay, and again, 5-axis, not a problem on there. I simulate that for you. Again, I'll do that in Machine Sim. We'll do a very similar type of toolpath, but what it's going to be doing is going to be building up that rad. Okay. Do those multiple passes. Not ideal to see, but you can see how it's put some sort of rad on there. It's better to see within the Solid Verify. So I'll just erase that through, just to show you how it's built up that rad. Okay, so that's the edge deburring with 5-axis. Okay. As I said, I just go into the tool. These are now all the tool types that are appropriate and available to use in this 5-axis edge breaking operation. Okay. So the next advancement is within geodesic machining. Okay, this isn't a new operation for 22, but it has been developed, and we expect that it's going to be more and more used as it develops even further. Okay, the idea of this is it's almost like a constant step over type toolpath. It can work in 3, 4, or 5-axis modes as well. Okay. The good side of the geodesic is that it's more automated than some of the other simultaneous machining operations. So if you haven't had a look at it, have a look at it, have a play with it. If you have any problems, obviously get in contact with us and we can try and give you a sort of a rundown and demonstration on how it works. Okay. One of the new things though that is within geodesic is we now have the option to use a medial axis. Okay. What that medial axis can do is basically provide us a really nice toolpath over a sort of a bit of a difficult surface. Okay, what it does is it takes that sort of medial axis and uses that as part of the drive geometry to allow you to have that constant step over type toolpath on something that it might struggle with if you're using, say, morph between boundary curves in a simultaneous 5-axis operation. Okay. We also have the options to round off corners. Okay, and I'll demonstrate this in a second. So we can remove any material. One of the downsides within a constant step over type toolpath, if you are looking at a surface such as on the right, is the material that's left in these sorts of sections where that step over doesn't allow it to get into those areas. I'll show you that in a second as to how that can be removed. So there's a lot within the geodesic that it can actually do. I'm just going to show you a couple of examples as part of this part. So starting off with just a general geodesic. So I can set this up to be in multi-axis. Okay, I have the option of multi-axis or 3-axis. For this one, I can use the model or I can use the surfaces. So if I want to be targeting the entire part or if I want to be targeting specific surfaces. So in this case, I've targeted these surfaces here. Okay, we've got our option to morph between two curves, and we're using the machining area to drive this toolpath. Just to show you in advance, I'm using what's called the extract flow curve. So what it's finding here is it's almost finding the longest edges on these surfaces, and it's using those as a driver for these this operation. So I'm not actually selecting any drive curves. So you see my drive curves are not actually filled in because SolidCAM is doing that work for me. Tool, standard ball nose, straight boundaries, all fairly familiar options within SolidCAM. Our tool axis control as well. So by doing that, we end up with a toolpath that looks something like that. Okay. I haven't specified those drive curves. I've just told it to effectively machine those surfaces, and with the options that I've selected, I've got that nice uniform toolpath all the way across there. As I said, it doesn't just work in multi-axis, also works within 3-axis. Okay. Again, works on a very, very similar principle. I'm telling it I'm doing these surfaces, and again, we're morphing between two curves using those extract flow curves, and it's given us a very, very similar toolpath, but only working within 3-axis. Okay. We can move on to this surface here. So what I'm doing here is I'm using a parallel to multiple curve strategy, and I'm using that medial axis. Okay, so the medial axis will be somewhere in the center of this. You can get a toolpath like that. As I say, it's more like a constant step over type toolpath. We can work from the center point if we wanted to. Obviously, if the geometry would allow for that, you could get some very nice toolpaths over some sort of dome type surfaces, anything like that. So this is the medial axis toolpath. Okay. So you can see this center will most likely be working off of that medial axis. Okay, and it's driving the toolpath then across the remainder of that surface. Okay, so it's a new feature within SolidCAM 22. Okay. And for certain geometries, that will be very, very handy. Again, in here, we've got our morph between our curves. Again, these will not be selecting any geometry in terms of the drive curves. These will just be using the geometry that SolidCAM is picking up on these surfaces. One other thing we've got is we've got our 3D boundaries now. So I'll just open up this toolpath just to show you this. If I was doing these fillets in here, okay, what I can do in my constraint boundaries is I can do our 3D boundaries. Okay, so as it stands at this point, I'm using a standard constraint boundary, and it's centered to the tool. So if I look at that from the top down, going to be sort of difficult to blend the rest of that. I need to extend this toolpath basically to make sure that I machine the entirety of those surfaces. Okay, so if I go to this operation, you see we're using a created automatically 3D boundary, but we're basing it off of the tool contact itself. Okay, so that is effectively expanding these toolpaths and providing that across the entirety of those surfaces to make sure that we do machine the entirety of those surfaces. Okay, so a very, very handy feature. And the final thing I want to show you in Geodesic is the ability to remove the corner. So as I say, we're looking at this part here. Try and angle that so it's a little bit easier to see. We're going to end up with some sort of material that's left in this sort of sharp corner here on all of these. We want to obviously avoid that. We want to have a nice surface. And what we can do is we can add some additional cuts. So you can see we've got the add medial axis. We're including this in the contours. Okay, so what that's doing is basically going to be, actually I'll show you, it'll be a little bit easier to show you. So bear with me a second. But what it's going to do, it's going to use the corners there. It's going to include those corners within the geometry. Okay, we'll get there eventually, just bear with me. So it's difficult to see, but you can just about make out that it's doing that corner move, okay, to try and remove that material as part of the geometry that it's looking at here. What we can do instead, which is a new feature for 22, still within that round corners, so we can do what's called a separate contour. So what that's going to do, we're going to do our standard sort of triangle type toolpath, work out to the next one, so on until it gets to the end of the geometry. It's then going to come back and it's going to do a single pass coming from the center to these corners, remove that material that might have been left there from the previous step overs. Okay, so just to show you that. So working our way in from the outside. So now we've just done a tool pass from the center into that corner there, removing the material that could have been left there. It's now going to do exactly the same into this sharp corner on the left hand side of the screen there. Another handy feature within SolidCAM 2022. So next thing we can have a look at is our multi-axis machining. So before, our multi-axis machining operation was sort of a simultaneous 5-axis roughing type strategy. We've now added for 22 the wall and floor finishing options as part of this operation. Okay, so we can now finish the walls and the floors using the barrel mills automatically. Okay, we just need to tell it what our wall and our floor surfaces are. Okay, we can also do rest material as well if we need to. I'll show you this all in a second. So we have a part that looks something like this, just to show you. There's some curvature in sort of all directions on this part. Okay, so a little bit difficult to do in that way. So as I was saying, just to show you this, we've got our multi-axis machining operation. You can see now we've got radial roughing, which was what it was in 2021, but we've now got wall and floor finishing in there as well. So I'll just take you through that very, very quickly. So we've got a wall finishing operation here. Our geometry, we're doing a parallel strategy. We can do a user-defined curve to drive that toolpath and the shape of that toolpath. Okay. Machining surfaces, it picks up the whole target, but then we focus this onto the wall or the floor surface, depending on what strategy we use in the technology. So the floor surfaces look something like that. We're including those corner rads as part of our floor surfaces. Our wall surfaces, I've selected the vertical walls for this. I've left out the rads in the center or in the ends there. I'll come back to them in a bit. Okay. And then our user-defined curve, we're doing this in 3 sections. We've got 3 curves, something like that. In terms of our tool, got an oval form barrel mill. Looks something like that. Okay. Levels, constraint boundaries, all very similar to the other parameters that we have within SolidCAM operations elsewhere. Doing a one-way strategy, and we're climb milling for this. Our tool axis control. This is a little bit different to the other strategies that we have within SolidCAM. So we can control the contact point here. So in this case, I've told it I want to be between 20% of the flute length up to a maximum of 60%. So I'm using more that barrel area of that tool. Okay, I can obviously fine tune this as it wants, but this is going to do a lot of the work for me. I've also got my lag angle here, okay, how I want it to lead into those corners, anything like that. Our links, we're using a clearance blend spline strategy, and we've also got a simplified gouge checking on this operation. So just to show you that toolpath, it looks something like this. Okay. So simulate that. Just do it in Solid Verify. It's working its way down the walls quite nicely. If it needs to change that lead or lag angle or the contact point, it's doing that all automatically for us. So you can see as we get into those corners, the tool itself is actually tilting to give us better access into those corners. You can see the tilt of this tool is changing as we go along that contour. Okay. So that is our wall finishing type operation. We also have a floor finishing operation as well, which works in a very, very similar way, just designed more so for doing any floor surfaces. Okay, so again, we've selected our floor finishing geometry, doing parallel to our longest dimension on our geometry. Our floor surface, simply just our floor surface, not including any of the fillet rads around there. And then our wall surface is everything else around that. Now, like that. Our tool, this time around, we're using a lens form barrel cutter. And everything else in here is pretty straightforward. And again, we've got the automated tilting and lag angle. Okay. Just simulate that for you. So you see how that tool is tilting as we go through that, or go through each contour. Okay, using that lens form barrel cutter as it's supposed to be used. Okay, final thing I will show you on this part itself, okay, is how we can actually use that geodesic machining to finish these corner rads. So you can see in here I've set up to do these two surfaces here. I'll just take you through that very, very quickly. Determined by number of cuts, we're shifting to the guide, which is going to be this here, parallel to multiple curves. It's effectively doing a pencil milling type strategy, but using the multi-axis functionality as well. Okay, so you can see, have a look at all our tool parts there. Should get a very nice finish against all of those fillet rads. Okay. Next thing I want to show you is our Turbo HSR calculation times and additional functionality within the fixturing offsets. So I'll show you this part in a second, but what we've done within the background of SolidCAM is we've improved the way that it calculates our toolpath. We can actually have a much faster calculation time. So you can see the comparison for the same part with the same parameters on the left-hand side for SolidCAM 21 and on the right-hand side for SolidCAM 22. You see there's a huge saving on some of these toolpaths. We've also now got the fixture offset. Okay, so we can actually use 2D sketches to define our fixturing. We can basically set areas where we don't want our tool to be going into. Okay, I'll show you that now. So this is the part from the presentation. Just to show you how quick this operation is, we're just going to clean out this part to begin with. So it doesn't know about the stock now. There's no toolpath that are saved, nothing like that. So I'm going to go in here, our geometry, going to change my global offset to be 0.5, just to make it have to think about things. Again, we've got our tool. One more step down. I'll go for a 2 mil step down just to change that so it has to think, do it as a fresh operation. So if I calculate that now, once it works out what the original stock material is, once it starts the calculation for the operation, you'll see how much faster that can be. So the actual calculation of that took about 3 seconds. A lot of that was working out the stock prior to it, after I cleaned out that cam part. So the other thing I wanted to show you on here is the fixture. Okay, so we can do it by surfaces or we can do it by extruding curves. Okay. Well, I've just deleted the sketch that I've just had, so bear with me just a second. So my extruded curves, something like that. So this is where I'm going to be clamping, say, on this part. Okay, so I've got that. I can then control how my tool is working around that. I can control my fixture height, any offsets, how close I want my tool to get to those fixtures. So if I recalculate that now, you can see in the tool path itself, it's now avoiding those areas. It's applying that 5 mil offset to keep the tool clear of those areas. That can be a very, very handy way of doing things if you don't want to be modeling all your fixturing. You've got very simple fixturing, for instance, like in this case, save yourself a lot of time in that. Next thing I want to have a look at is the automatic feature recognition and the edge deburr specifically. Okay, so beforehand, we didn't have any way to actually filter out any chains. You could effectively select a face and it would do all the edges on that face. And your options were you do all the edges on that face or you do none of the face. Now we can actually filter these chains. Okay, and I'll show you how that works now. So I've got this nice large part. It's about 1/2 meter by 1/2 meter. Okay, I don't want to be going through there. I don't want to be having to select each edge and do them all individually. Okay. So I've already roughed and finished it. I've done that with our pocket recognition software. What I'm going to do is I'm now going to create a new edge deburring recognition. I'm going to create some new geometry. Okay. I want to be applying some filters. I don't want to be doing any of the holes on this, so I'm just applying that minimum diameter like that. Now it's going to pick up all the edges that meet the criteria that I'm at. Okay, so you see it hasn't picked up these holes, but it has picked up these through edges here. So just to give you an idea, if I look at my updated stock, in the previous operation, I haven't machined through this. Okay, I don't want my chamfer obviously to try and put these edges on because it's not needed. Okay, it's going to damage my tool. It's going to cause me issues. So what I need to do is I need to actually get rid of those chains. Beforehand, I'd only be able to select this face, basically unselect it. Now I can select this face. So I've just selected that face. It's told me that's face 10. See, I've now got 2 chains in here. If I get rid of chain 13, I'm now going to be doing the outside there. I want to do exactly the same for all the other faces. So we have that like that. Bring it a tool. Our levels, we'll put a 0.25 chamfer on. Again, this is all very, very familiar in that it's pretty much the same as in 2021. So I'll just calculate that, just prove to you we're now no longer doing this feature here. We're not trying to chamfer that. See, I'm chamfering around it, but not that feature itself. So that's the edge deburring and the progression that we've had on there. Okay. The next one is how we can select tools from the machine preview now. Okay. So when we're working on complex sliding head type machines, you have a lot of tools in there. The tool table can get quite busy, okay, and that's where this can come into its own. Okay, so what we can actually do is we can use the machine preview within the operation window, and we can select the tool from that machine preview. Okay. We can also do this on any spindle type turrets. Okay, we can basically, as you can see on the right hand side there, we can select a tool component. We can then select it from the tool number. Okay. If we've got our toolkit already open, we can also find what that tool element is within our toolkit, as you can see in that image there. So how does this actually work within SolidCAM itself? So let me find the part. If I'm looking at this part here, okay, quite a simple part, okay, but maybe I've got my machine that's set up for something that's a little bit more complicated. So at the moment I'm working on a Star SX38. If I have a look at my toolkit, you can see there's a number of tools that are in there. Okay. I'll just show you this from our machine preview. Got our turret, which is full. And we've got a pretty full machine there in terms of the tools that are available. If I can avoid it, I don't really want to be going into here, sort of trying to find where that tool is that I want to be working on. So I'll show you how this works. So I'm just going to create a simple drilling operation on the back spindle. Okay. We've got our tool here. I'll bring up my machine preview. I can now start selecting the tools. So for instance, if I wanted this as tool 22, I can right click on it, select that tool component. That brings that through into my operation. If I have a suitable tool on my turret, I can do the same thing. So in this case, I want to be selecting, say, tool 39. Okay. It's now picked that up. Okay. Again, it will depend on how I'm wanting to machine this part. We'll go back to tool 22. Okay. We'll close that off. Now I'm just going to do this ever so quickly. About like that. I'm going to do something very similar with the drilling operation. Okay, so obviously I don't want to be using my spot drill. I'll go to my machine preview. Go with tool 26. Okay. So I can speed up your tool selection no end. So now all I need to do is adjust that like that. And that's ready to go now. Okay, so it can be a real time saver doing it in that method. Undercut milling. Okay, so this is something within sort of the THSR, THSM type operations. Okay, and what we can do now is we can actually remove any air cutting. So this is best shown on the actual demonstration. So I'll just get that open for you. This is the last demonstration of this morning. I'll also take you through some of the upcoming changes, okay, upcoming developments. So, standard undercut milling operation. Got our lollipop cutter, constraint boundary, just constrain it to that inner pocket, step down, and we're machining only the undercuts first. If I calculate that, see we've got something like that. Okay. On this one, I haven't done any dynamic holder checking, so what that's actually going to do is going to plow through into that job. In a second, as it gets further down, start hitting that shoulder. Okay. So, not an ideal operation, not at all. What I can do is I can refine that a little bit. Okay. So I'm still using the same geometry, still using the same tool. I have used now the dynamic holder checking to avoid crashing that tool. Same constraint boundary, same step down. I save and calculate that. It's going to be better in that it's not going to crash. But as we get further down here, we are going to be doing air cutting. So new to 22, we now have the option to remove any of these air cuts. So if I do that now, it's only going to machine now where that tool can actually cut. So you can see we're not now going down to the full depth, just to show you what those air cuts look like. You see down the bottom, our tool is obviously not going to be contacting because of the size of the tool. Now it knows that it can't get down into this section here, so it's cutting that section of the tool path out. So that's the undercut milling strategy. So, as I say, that was the last demonstration for this morning, but I will just show you some of the other general improvements that we have within SolidCAM 22, as well as an idea of what we have in the pipeline moving forward. So, one of the other options that we have is we can now customize our setup sheets. So, this is all now done online. It's very, very simple to use. You create your setup sheet on the online website. You can then download that configurator or that template, install it, and then use that going into the future. So this means, of course, that you are able to fully customize your setup sheets. So you can show the information you want, obviously get rid of any information that you do not want. Machine setup. Okay. Your machine options, you can now reset the values to be default. So if in your initial setup you change something and you want it to go back to the default, you can now do that. You can select multiple parameters at the same time. And we've also added in a description to hopefully make things a little bit more user-friendly there. In our setup, okay, we can actually now use equations. Okay, it works as well for our MCOs, machine control operations. So for instance, if you wanted to have an equation, for instance, for the back of a part, say your part is 100 mil, in this case you can add 50 mil on to whatever you're trying to do here. So rather than you having to get the calculator out, you can let SolidCAM do a lot of the work there for you. Okay. We can also add in equations and functions. So for instance, to save any confusion, some people work off of diameter, some people work off of radius. We can create now functions. So if you want to convert between the two, make life a little bit easier for all that are using the system, we can now do that. We can import any custom messages through the MCO window, and we can now also resize the MCO window. Turbo HSR and HSM filtering. So In some cases, you're going to be wanting to avoid some areas. So now we have a new option as the circumscribed circle. We can actually filter out areas and avoid our tool going into those areas in that way. Can be very, very handy, as I say, if you're just trying to avoid any areas for roughing. Saves you having to do anything in terms of the constraint boundary instead. We also have the option of a minimum pass length. So sometimes within HSR or HSM, you end up with some small passes. What we can do now is we can filter these out and remove them and aid our cycle time. So onto the upcoming features. Eye turning. Okay, so like eye machining, but working on the turning side of things. Okay, so we already have the trachoidal turning toolpath, but in this case, what we can do is we're now going to have the eye turning, which is going to support all the insert shapes, and it's going to be easier on our machine, increase our tool life, and reduce any machining loads. Further turbo HSR improvements. We are now going to have in future, we're going to have the option to include an arc fit. Okay, so this should decrease the size of our G-code. As you can see, the lines will be reduced as it uses this arc fit parameter to remove any lines, any G1 movements, and replace them with G2 or G3 movements. We also have the option for the default fallback sequence. Sorry, we are going to have the option for the default fallback sequence, so we can control our links in a better way, remove any unnecessarily high links. Okay. We're working on the functionality for the 𝒆𝒐, the free turn and the Sandvik prime turn support. So those of you probably already know about this. We can use a tool for multiple different operations, and we're going to be adding the functionality to be able to do that within SolidCAM in the near future. Prime turning, very, very similar principle where we can turn in all directions. Again, this sort of functionality is going to be available in the near future within SolidCAM 22. Thread whirling, more so used for any long type threads or high precision threads. Again, it's going to be something that is going to be coming through into SolidCAM in the near future, mainly used on our Swiss type CNC machines, can be used elsewhere. We're now adding also additional functionality for any collinear or U-axis support, so any like oil and gas, large parts, large machines, anything like that. We're starting to build this in to the VMID files and into SolidCAM itself. Okay. One of the more important ones that will be coming out is the ability to do any custom shape threading. So we'll be able to produce custom threads within SolidCAM 22. You're not going to be limited to your standard threading inserts, your standard threads, thread forms, anything like that. So we should be able to get that sorted again into the near future. And that is everything from me this morning. If you have any questions, feel free again to use the chat. Okay, I'll keep this open for another minute or so. If you're an existing customer, you require support, or you have any questions after this seminar has concluded, you can always log into the support portal and raise a ticket with us and our team, and we will get back to you on that. If you're wanting some more information within SolidCAM and you're not an existing customer, feel free to give us a call on the number at the bottom of the screen there. As I say, I'll leave this open for another minute or so. Okay, thank you for your attendance. I will conclude the seminar then at that point. If you have any questions, as I say, and you're an existing customer, feel free to log a ticket with us or give us a call on the number below.